Today we'll discuss exceptions and input and output in Java. We'll discuss the purpose of exceptions, exception messages, the call stack trace, the try-catch statement, exception propagation, the exception class hierarchy, input and output exceptions, and writing text files. So exceptions. An exception is an object that describes an unusual or erroneous situation. Exceptions are thrown by a program and may be caught and handled by another part of the program. A program can be separated into a normal execution flow and an exception execution flow. An error is also represented as an object in Java, but usually represents an unrecoverable situation and should not be caught. Exception handling. The Java API has a predefined set of exceptions and errors that can occur during execution. A program can deal with an exception in one of three ways. You can ignore it, or you can handle it where it occurs, or you can handle it at another point in the program. The manner in which an exception is processed is an important design consideration. So uncalled exceptions. If an exception is ignored by the program will terminate abnormally and produce an appropriate message. The message includes a call stack trace that indicates the line on which the exception occurred and shows the method call trail that leads to the attempted execution of the offending line. The try-catch statement. To handle an exception in a program, the line that throws the exception is executed within a try block. The try block is followed by one or more catch clauses. So in Java, you handle an exception with a try and a catch statement. Each catch clause has an associated exception type and is called an exception handler. When an exception occurs, processing continues at the first catch clause that matches the exception type. So you can have many catch clauses associated with your try block, each handling a different exception. The finally clause. A try statement can have an optional clause following the catch clauses, designated by the reserved word finally. The statements in the finally clause are always executed. If no exception is generated, the statements in the finally clause are executed after the statements in the try block complete. If an exception is generated, the statements in the finally clause are executed after the statements in the appropriate catch clauses. Exception propagation. An exception can be handled at a higher level if it is not appropriate to handle it where it occurs. Exceptions propagate up through the method calling hierarchy until they are caught and handled, or until they reach the level of the main method. I think it's technically they propagate down through the method calling hierarchy. So the main method is always at the bottom of the call stack, and then the stack goes up. So in the propagation code example that we did, method level 1 is here, method level 2 is here, and method level 3 is here. So the deeper you go into the methods, the higher the stack becomes. So when you propagate down from method level 3 back to method level 2, then you propagate down from method level 2 back to method level 1, and then you propagate back to main method if you handle it in main. So exceptions propagate down through the method calling hierarchy until they are caught and handled, or until they reach the level of the main method. Then will terminate abnormally. A try block that contains a call to the method in which an exception is thrown can be used to catch that exception. An exception is first thrown from the top of the stack, and if it's not caught, it drops down the call stack to the previous method. If not caught there, the exception again drops down to the previous method, and so on until they are caught or until they reach the very bottom of the call stack. So if it reaches the very bottom to the main method and it's still not caught by the main method, then the program is going to terminate abnormally. This is called exception propagation. So top of the call stack, and then bottom of the call stack, and the exception occurred in method level 3. So it's going to propagate down to method level 2, then propagate down to method level 1, and then propagate down to the main method. If it's caught and handled in method level 1, then it won't propagate down to the main method. So the exception class hierarchy. Classes that define exceptions are related by inheritance, forming an exception class hierarchy. All error and exception classes are descendants of the throwable class. A programmer can create an exception by extending the exception class or one of its descendants. The parent class used depends on how the new exception will be used. So this is just a diagram of part of the error and exception class hierarchy in the Java API. So object is the highest, is the biggest superparent. So it's at the very top of the hierarchy. And throwable extends object. That's why in UML it's denoted with an open arrowhead. Extending inheritance is designated with an open arrowhead pointing from the child to the parent. So from object it goes down to throwable, and throwable has two children, error and exception. And then error has a bunch of children, and then exception has a bunch of children, and then runtime exception extends exception, which also has a bunch of children as well. Checked exceptions. An exception is either checked or unchecked. A checked exception must either be caught by a method or must be listed in the throws clause of any method that may throw or propagate it. A throws clause is appended to the method header. The compiler will issue an error if a checked exception is not caught or asserted in a throws clause. Unchecked exceptions. An unchecked exception does not require explicit handling, though it could be processed that way. The only unchecked exceptions in Java are objects of the runtime exception, or any of its descendants. Errors are similar to runtime exception and its descendants in that errors should not be caught. Errors do not require a throws clause. The throw statement. Exceptions are thrown using the throw statement. Usually a throw statement is executed inside an if statement that evaluates a condition to see if that exception should be thrown. I/O exceptions. Let's examine issues related to exceptions and input and output. So I/O stands for input and output. A stream is an ordered sequence of bytes that flow from a source to the destination. In a program, we read information from an input stream and write information to an output stream. A program can manage multiple streams simultaneously. The three standard input streams are system.in, which is the standard input stream, system.out, the standard output stream, and system.error, the standard error stream, which outputs for error messages. We use the system.out when we execute println statements. System.out and system.error typically represent a particular window on the monitor screen. System.in typically represents keyboard input we've used with scanner objects. System.in can also represent scanning from, for example, a text file or something like that we also did in another example in the previous video. The I/O exception class. Operations performed by some I/O classes may throw an I/O exception. A file might not exist. Even if the file exists, a program may not be able to find it. the file might not contain the kind of data that we expect. An IO exception is a check exception. So, writing text files. We've used the scanner class to read input from a text file in videos before. See the other previous videos. Let's now examine other classes that let us write data to a text file. The file writer class represents a text output file, but with minimal support for manipulating data. Therefore, we also rely on the print writer object, which have print and println methods. We built the class that represents the output file by combining these classes appropriately. Output stream should be closed explicitly. In the example code, we looked at a program that writes a text data file with 2 random digit numbers, and it looks like a 2D array output. So this concludes our discussion on exceptions and input and output. Hope it helps. Thanks.